Welcome to Study Loop.
So the first thing we're taking a look at here is the molar flow rate of dry air and converting it into units of moles per hour. So we have n dot air equal to 7.01 times 10 to the 5 moles per hour. So according to our flow chart, we have 5 unknowns. We have 0 degrees of freedom. So moving on to the second part that we have here, we can calculate the volumetric flow rate, that is B dot. That is equal to 2.3 times 10 to the 4 meters cubed per hour. And then we can also calculate the relative humidity. That is 2.8%. And we can also determine the required temperature of inlet air. To be 181 degrees C. And so small droplets do have larger surface unit area per unit volume, so we have a greater interfacial area between the droplets and the hot air, then we will have faster evaporation as a result. So droplets can fall to the bottom of the dryer, and if the size of the droplets are big, as a result the droplets will puddle rather than being suspended in the hot air and the dry solids being carried out of the dryer. So if less water is evaporated, there will be less heat to be transferred from the inlet air to the polymer solution, due to which gas outlet temperature, which remains above 110 degrees Celsius, and the wet temperature remains below 110 degrees Celsius. So in the extreme case that we have no evaporation occurring, the gas and solution temperature will be close to their respective inlet values of 181 and 25 degrees C. Therefore, as the outlet temperature of the emerging gas increases, so the effect of the volumetric flow rate can't be determined without doing calculations. And lastly, the relative humidity does decrease.